Enceladus. It orbits Saturn at a distance of roughly 148,000 miles away from Saturn, so close that the swirling storms and massive rings of the gas giant would completely dominate the Moon's sky. It is a small world, measuring just 313 miles across. Basically, you could fit this entire Moon comfortably within the borders of Arizona. At first glance, it does not look like a sanctuary for biology. It is completely encased in a blindingly white shell of solid ice. Enceladus has a geometric albedo of 0.99, meaning it bounces nearly 100% of the weak sunlight that hits it back into space. Because of this extreme reflectivity, the surface temperature rests at a staggering negative 330 degrees Fahrenheit. When the Cassini spacecraft arrived at the Saturnian system in 2004, scientists expected Enceladus to be a dead, frozen wasteland. But as the probe flew past, its magnetometer picked up a glaring anomaly. The massive magnetic field of Saturn was bending and bowing around the tiny moon in a way that made no mathematical sense. Something was physically pushing back against the magnetic field. To figure out what was happening, scientists commanded Cassini to take a closer look. The probe found that Enceladus was not a dead rock, it was erupting. And recent analysis shows that it isn't just erupting at supersonic speeds, it is violently ejecting the very ingredients of life. Near the south pole of Enceladus, Cassini photographed 4 massive parallel fractures carved deep into the ice crust. Astronomers named them the Tiger Stripes. They officially designated them Alexandria, Cairo, Baghdad, and Damascus. From these colossal canyons, Enceladus was firing towering geysers of water vapor, ice particles, and gas hundreds of miles at over 800 miles per hour into the vacuum of space. The eruption is so violent and continuous that the Moon's gravity cannot hold onto the material. The ejected ice shoots into space and actually forms Saturn's outermost ring, called the E-ring. Enceladus is literally paving its own orbit with frozen ocean water. Now, if water is shooting out of a frozen moon at such speeds, it proves there is a liquid ocean trapped beneath the ice crust. Gravity and density measurements suggest the subsurface ocean of Enceladus is roughly 6 miles deep. That's almost as deep as the Mariana Trench. But how? If the sun is not providing the heat, what is keeping this massive body of water from freezing solid? The answer is gravity, specifically a cosmic tug-of-war. Enceladus does not orbit Saturn alone. It is locked in a gravitational dance with a neighboring moon called Dione. For every 1 orbit Dione completes, Enceladus completes exactly 2. Every time the moons pass each other, Dione's gravity gives Enceladus a slight tug. This rhythmic pulling forces Enceladus into an eccentric oval-shaped orbit around Saturn. Because the orbit is an oval, Enceladus is constantly moving closer to and further away from Saturn. As it moves closer, the gas giant's immense gravitational pull strengthens, physically stretching the entire tiny moon. As it moves further away, the moon relaxes. This relentless squishing and stretching creates immense internal friction deep within the rocky core. The rock physically rubs together and generates massive amounts of heat. This process is called tidal heating. It acts as a colossal internal furnace, melting the ice from the bottom up and maintaining that 6-mile-deep liquid ocean in the darkest reaches of our solar system. Discovering a subsurface ocean nearly 900 million miles from the Sun was a monumental paradigm shift. Suddenly, the frozen outer edges of the solar system didn't look so dead anymore. In 2015, NASA dropped Cassini to an altitude of just 30 miles above the surface and flew it directly through the erupting plumes at 19,000 miles per hour. As it tore through the geysers, an instrument called the Ion and Neutral Mass Spectrometer physically tasted the alien water. In earlier passes, scientists had detected simple organic molecules like methane and ethane. But the word organic in chemistry simply means a molecule contains carbon. Simple organics are abundant in the universe. You can find them on dead asteroids and floating in empty nebulas. They do not automatically mean biology. But a landmark paper published in 2018 analysing that deep dive data revealed something entirely different. Cassini detected complex organic macromolecules. These were heavy, intricate structures containing hundreds of atoms, forming complex carbon rings. These are the heavy-duty chemical structures required to assemble amino acids, build proteins, and eventually construct living cells. To figure out what was happening at the bottom of the Enceladus Ocean, scientists looked at the bottom of our own. Plunging thousands of feet into the Atlantic Ocean, far removed from any sunlight, there are deep cracks in the Earth's crust known as hydrothermal vents. Here, boiling, mineral-rich fluid heated by the magma within the Earth spews out of limestone chimneys and mixes with the freezing seawater. This violent interaction triggers a geological process called serpentinization. The iron and magnesium-rich rock reacts with the seawater, producing heat, hydrogen gas, and the exact kind of complex organic molecules Cassini tasted at Saturn. Surrounding these vents on Earth are thriving ecosystems of tube worms and bacteria that survive entirely on chemosynthesis, eating the chemical energy spewing from the rock. The data from Cassini strongly suggested a similar process is happening right now inside Enceladus. We had the deep water, the heat, and the complex carbon. But for years, there was a massive piece of the puzzle missing. Astrobiologists look for a specific chemical recipe to determine if a world is truly habitable. It is an acronym called CHNOPS. It stands for carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. These are the 6 essential building blocks of all known life. Cassini had easily found 4 of them: carbon, hydrogen, nitrogen, and oxygen, in its early flybys. But phosphorus and sulfur remained incredibly elusive. Phosphorus is the backbone of the DNA double helix. It is also the core component of ATP, the molecule that every single living cell uses to store and this incredible evidence. You might be asking an obvious question. If the ocean is perfectly primed, churning out the exact chemicals needed for biology, why didn't Cassini just find the alien life itself? The answer comes down to engineering. Cassini was built to be a weather and geology satellite, not a biology lab. Its instruments were designed to weigh molecules, measure magnetic fields, and identify basic chemistry. They simply lacked the microscopic resolution and the specific technology required to detect a living cell or sequence a strand of alien DNA. Cassini couldn't find actual alien life because we didn't give it the eyes to see it. It was searching for the smoke, not the fire. However, with its data, we now have a beautifully complex picture of an entirely alien astrobiological reactor. We have a vast ocean of liquid water. We have a steady, reliable heat source. We have a rocky seafloor producing hydrogen gas. Now we need a next-generation space probe to go back, lean over the edge, and actually look. Until then, Enceladus remains one of the most compelling targets for discovering life beyond Earth.